What would happen if we reversed gravity? In this case, it means that instead of pulling us down to the Earth, it would push us away from the planet. This is what's known as anti-gravity or negative gravity. But how would life on Earth be affected if suddenly our feet were glued to the ceiling? In theory, anti-gravity doesn't exist, but there are forces that can oppose gravity. For example, magnetic repulsion and the pressure exerted by a fluid like water can counteract gravity's downward pull. However, these forces are always relative. There is always something more massive than the object pulling it back down to Earth. And so, an object will only float or seem to fly when the force pushing it up is equal to or greater than the force of gravity pulling it down. Once that balance tips in the other direction, the object falls back to the ground. But what if gravity itself was reversed? Could we walk on the ceiling? In this video, we're going to take a look at what would happen if gravity turned around. All of the laws of physics tell us that gravity should always pull objects towards each other. It's just what happens. The bigger an object, the stronger its gravitational pull, and the closer an object gets, the stronger the pull becomes. On Earth, we experience a force of gravity of 9.8 meters per second squared. And that S because the Earth is massive enough to warp space-time around it and form a sort of gravitational well that everything near it falls into. That includes you, me, birds, buildings, rain, clouds, and even light. Anti-gravity would mean that this force was reversed, and that, instead of being attracted to each other, objects would be repelled by each other. So let's imagine that the Earth suddenly started to reverse its gravitational polarity. We know that not everything on Earth would instantly start flying away from the planet, because there's no outside force to pull them up. So what would happen to us? If we were walking next to each other on the street, we'd be pushed apart by a force equal to the strength of our gravitational attraction to one another. This force would depend on our masses and the distance between us, but it could get pretty strong. Suddenly, people would be launched off their feet and flung through the air in random directions. People who are close together, such as those sitting on a bus or train, would be thrown towards the nearest wall or window. Those in cars might be blasted through the windshield. Those might be slammed into buildings, while still others would be shot directly up into the sky. The atmosphere would also be affected by this sudden reversal of polarity. Air molecules would be pushed away from the Earth's surface and expand outward, creating a shock wave that would race around the globe. This would cause widespread damage to buildings, infrastructure, and the natural environment. Birds, planes, and rockets would be flung into the upper atmosphere, where they'd burn up due to friction. Satellites would lose orbit and plummet back to Earth. All the planets in the solar system would be affected by this change in polarity. They would all start moving away from the sun and head out into deep space. The moon would be the closest celestial body affected by this shift, and it would start drifting away from the Earth. After a few weeks or months, it would stop orbiting the planet altogether and become a rogue object in outer space. The Earth's oceans would be completely drained during this process. All the water would be sucked up into outer space until the planet was left dry and lifeless. But what would happen to us once we were free of the planet's gravitational pull? We know that anything not tethered to Earth would drift away from the planet. But what would happen to the planet itself? How would it fare without its gravitational pull? For starters, the Earth would start to shrink. Without gravity holding it together, the planet's atmosphere would dissipate into space, leaving behind a shriveled-up rock. The Earth wouldn't be the only thing affected either. All of the other planets in the solar system would also begin to shrink. Without their gravitational pulls, they too would lose their atmospheres and become barren rocks. But what about the sun? What would happen if it lost its gravitational pull? If the sun stopped pulling in matter and collapsed under its own weight, it would implode. The star's core would be blasted out into space, and the remaining material would collapse in on itself. The Earth would be plunged into darkness, and the solar system would descend into chaos. Some scientists believe that this scenario is actually what happened to the planet Mercury. The star's gravitational pull has stripped Mercury of most of its atmosphere, and the planet is now scorched on one side and frozen on the other. Without gravity, life as we know it wouldn't be possible. Stars wouldn't shine, galaxies couldn't form, and planets would be barren rocks floating through endless space. Even our bodies would fall apart. Without gravity, our muscles, bones, and organs would literally break apart. We'd turn into balls of plasma, and get blown away into the farthest reaches of the universe. And so it seems that we should be grateful to have a planet like Earth, a place with gravity that keeps us grounded and gives us the stability we need to survive. But let's say for a moment that anti-gravity did exist. How could we use it to our advantage? Well, it might not be possible to reverse the direction of gravity on Earth. It is possible to create anti-gravitational fields using lasers or other forms of energy. These fields can then be used to levitate objects. One example of this is the work being done at the University of Göttingen in Germany. There, scientists have developed a way to use lasers to levitate diamond particles in midair. By trapping these particles in an anti-gravity field, the researchers can study their properties in ways that were never before possible. Another example can be found in the work of the late Professor André Geim at the University of Manchester. He developed a technique known as the Casimir effect to levitate small objects using a vacuum chamber, by placing 2 plates inside the chamber and then removing most of the air. He was able to create a low-pressure environment that had a repulsive force against the plates. This force was strong enough to lift small objects such as a human hair. Perhaps one day we'll be able to develop anti-gravity fields strong enough to allow us to walk on the ceiling. But until then, we'll just have to enjoy watching levitation experiments from the safety of the ground. Someday, thanks to scientific advancements, we may find a way to make anti-gravity a reality. But until then, we can marvel at the fact that the world doesn't turn upside down every day. It's a relief that the ground beneath our feet stays firmly planted in the right direction. Otherwise, we'd all be floating away into outer space. Wondering what wild what-if video is next? Check this one out instead. Don't forget to like and subscribe for more awesome science.